have a theory about the missing scientists, but you guys have to bear with me. It starts here with this article from the Journal of Modern Physics in 2024 called Extraterrestrial Life in the Thermosphere, Plasmas, UAP, Pre-Life, Fourth State of Matter. So basically these UAPs are these plasma balls that are like a kilometer wide, and they represent what physicists are calling the closest related to pre-life. And these plasmas represent the fourth state of matter. The article reads that these plasma are attracted to and may feed on electromagnetic radiation, and they have different morphologies: cone, cloud, donut, and spherical cylinder, and have been filmed flying towards and descending from the thermosphere into thunderstorms, congregating by the hundreds and interacting with satellites, generating electromagnetic activity, approaching the space shuttle. And there's talks that these plasma is what's seen around the Malaysian air flight that went missing. Just before a hole was ripped into time-space, the plane disappeared and it closed. Okay, so let's get back to our scientists. Who are they and what were their jobs? Let's start here with McCaslin. William Neil McCaslin is an astronautical engineer. Astronautics is a practice of sending spacecraft beyond Earth's atmosphere into outer space. Astronautics can be used in quantum physics by enabling experiments in microgravity, which allows for more precise measurements and observations of quantum phenomena. And the research company CERN does just that, observes quantum phenomena. Let's run through a list of our other scientists now. We have Michael Hicks. He's passed away. He worked at the Jet Propulsion Laboratory studying deep space. Then we have Monica Reza. She is missing from the Jet Propulsion Laboratory. McCaslin's missing. We have Amy Eskridge. She's passed. She studied anti-gravity technology in UFOs and extraterrestrials. Then we have Steven Garcia. He is missing. He's a government contractor in national security. Then we have another one, national security. Then we have Anthony Chavez, Los Alamos National Laboratory, he's missing. We also have Melissa Casillas, Los Alamos National Laboratory. What does Los Alamos National Laboratory do? It studies areas of quantum research. Los Alamos National Laboratory focuses on these areas: nuclear research, fundamental science, national security, and quantum cryptography. If you don't know what quantum cryptography is, don't worry. It's essentially national security on a quantum level, encrypting things on a quantum computers would create the quantum keys to unlock these transmissions. Quickly, let's talk about what Jet Propulsion Laboratory does. It works on planetary robotic spacecraft, Earth orbit missions, and astronomy. Circling back to our girl, Amy Eskridge, what does she study? She studies anti-gravity technology, UFOs, and extraterrestrials. Quickly, what is anti-gravity? Anti-gravity refers to the theoretical concept where a force would counteract gravity, effectively allowing objects to float or move without the influence of gravitational pull. It's the opposition to gravity. Under current physical laws, particularly general relativity, anti-gravity is deemed impossible. Gravity is always attractive and does not exhibit repulsive properties. Okay, now what does CERN do? CERN studies antimatter. CERN slows down antiprotons with an antiproton decelerator so that physicists can investigate their properties. Antimatter is what happens when CERN takes its little light beams and spins them around the circle really fast and uses a whole bunch of magnets to bend and twist those beams until eventually they collide and explode two particles together and create the moments that happened just after the Big Bang Theory and recreate antimatter, because all of the antimatter that was created at the beginning of creation is now gone. So they have to create antimatter to figure out where it went. Theoretically, they thought that antimatter would exhibit anti-gravity, but it does not. Antimatter is affected by gravity. Now, remember, we mentioned cryptography as a source of national security, encrypting things on a quantum. CERN utilizes quantum cryptography primarily for secure communication and data transmission, leveraging the principles of quantum mechanics to protect sensitive information from eavesdropping. This technology helps ensure that data exchanged between researchers and facilities remains confidential and secure against potential cyber threats. And NASA uses cryptography to send information across long distances without that information getting hacked. Now, finally getting to the meat and bones of the situation, the Large Hadron Collider needed to upgrade in the 2020s. The LHC is one of the largest scientific instruments ever built. To sustain and extend its discovery potential, it will need a major upgrade in the 2020s. This will increase its luminosity, the rate of collisions by a factor of 5 beyond the original design value, and the integrated luminosity, total collisions created by a factor of 10. Member states of CERN are required to uphold their end of the bargain, and that means that they will provide money, resources, and knowledge, talent to work on things at CERN when the procurement time is allotted. And I wonder how much money, how many resources, and what talent was needed for this upgrade. Don't worry, I wrote it down. They need for this aluminum, copper, fiberglass braided insulation, iron, low carbon steel, stainless steel, NB3SN, which is some kind of titanium. No, it's tin. ND3SN is. These guys, crab cavities, need ceramics, copper, titanium, and stainless. Anyway, you get the idea. Basically, we need aluminum, copper, tungsten, fiberglass, iron, steel, titanium, stainless steel, graphite, something called molybdenum, I don't really know what that is, tin, titanium, and helium, and all kinds of fuel, electric, which they get from France. And comparing the list of member states to the resources that CERN needs and who exports specifically these resources to CERN, we have aluminum comes from Canada, Russia, and the UAE. Copper comes from Chile and the Congo. Tungsten comes from Spain, Bolivia, and the European Union. Iron comes from Australia, China, Ukraine, India, Brazil, Canada. They are getting their titanium from China, Japan, Russia, and Australia. Russia gets its titanium from the Ukraine and Kazakhstan. Their stainless steel comes specifically from Indonesia and the UK. And their graphite comes from China. Their helium comes from the United States, who gets it domestically. Their helium also comes from Qatar and Algeria. And they get their fuel, electric, from France. And in case you're wondering, CERN's data center runs 450,000 processor cores 24/7 and 10,000 servers. That is roughly 1.3 terawatt hours annually. However, it peaks at 200 megawatts between May and December when it turns on the Large Hadron Collider.